Hey everyone, it's Jason from Code Monkeys and welcome to another Code Monkeys tutorial. This is the beginning of a series on basic machine learning. Specifically, it will cover simple image classification. So we will first demonstrate how to download and examine the data, and we will start off by cloning the repository. A link to the repository can be found in the description of the video. And to clone the repository, we simply need to click the clone or download button, copy the link, and then type in the command get clone in the terminal, and then paste the link. And I've already cloned the repository, so I will not be running the command. And this will create a directory containing all of the files from the repository, so be sure to clone it in your preferred directory. I cloned it in my repos directory, and since I've already cloned the repository, I can simply cd into it. And now that you have cloned the repository, we need to install the required packages needed to run the code in this series, which can be found in the environment.yaml file. And we will be using the anaconda command, conda env create flag file, and then the name of the YAML file, which is environment.yaml. And this will create the conda environment, and its name will be CNN. And I'm not going to run the command since I have already installed the necessary packages, and creating the environment will take some time, so be sure to pause the video until your environment is created. Alright, so now that you have created the environment, we can activate the environment using the conda command, conda activate CNN. And now we need to open up the Jupyter notebook using the following command, Jupyter-lab, and then 01, and we'll tab complete the rest of the file name. We'll let this load for a second, make this full screen. And as mentioned before, this video covers data exploration, and this notebook will show you how to download and examine the data for simple image classification, and we will be specifically going over how to download the data, examine the structure of the data, and performing the exploration. So we start off by importing the necessary packages. We will be using path to navigate and access the directories and files, and Seaborn will be used to draw statistical graphs, and matplotlib will be used to display the images, and we will use pandas to create data frames that Seaborn will be able to use to plot some basic statistics about our data. So after importing the libraries, we now need to download the data. And we will be using the Imagenette 160 dataset, and this dataset is provided by FastAI, and a link to the dataset is also provided in the description of the video. And Imagenette 160 is a subset of the Imagenette dataset, and it contains the following 10 classes: tench, English Springer, cassette player, chainsaw, church, French horn, gas pump, golf ball, and parachute. And the 160 refers to the number of pixels in the images, and by using a smaller dataset, the amount of time needed to train a model will be greatly reduced, which is useful for testing out new ideas and for learning purposes. And this dataset can be downloaded by using the shell command that you see in the cell there. And note that you need to have curl installed, which can be installed on Ubuntu using the following command, sudo apt install curl in the terminal. And also notice the exclamation point that is needed to run the shell command inside of the Jupyter notebook. And this will also take some time to download, so be sure to pause the video. And I've already downloaded it, so I will not be running this cell. Alright, so now that you have downloaded the data, we need to extract the contents of the dataset by running the following command that you see in the cell there. And note the capture command is used to prevent the display of the files. And also the capture command only applies to the cell it is being run in, and it must be run before any other code, including comments. So we can extract the contents. And now we are going to examine the structure of the data. So first we are going to define a path to the train directory, which can be found in the Imagenette 160 directory. And now we are going to loop over each directory in the train directory and print out the name of each directory. And Notice that these names of the directories are not very descriptive, so to make them more descriptive, we are going to create a list of class names, which we do in that cell there, and you see the list of class names. Now we will enumerate over the directories found in the train directory to rename each directory. And here D refers to a specific directory in the train directory, and I is used as an index, which is used to access each element of the class names list. So we can run that cell. And we rename each directory by concatenating the corresponding element in the class names list. So the first directory will be renamed Tench, since the first element in the class names list is Tench, and the second directory will be named English Springer, since the second element in the class names list is English Springer, and so on. And if we go to the Imagenette directory in the file structure, and we go to the train directory, we'll see the class names right there of all of our directories. And notice that the Jupyter Notebook will alphabetize the directories, so they will not appear as Tench, English Springer, Cassette Player, etc. in the file structure. They will instead be organized alphabetically. And after doing this for the training data, we need to do it for the validation data. And the training data will be used to train the model, and the validation data will be used to tune the hyperparameters of the model. Okay, now we're going to scroll down, and now we are ready to explore the data. So we first create an empty list called images, which will be used to store the first image of each class. And to get the first image of each class, we are going to loop over each class name in the class names list and access each directory in the train directory by passing in the path to each directory, to the path module by concatenating the class name to each path, and we then read the first file contained in each directory in the train directory using matplotlib's imread method, and this image is then appended to the images list. And we will run that command and scroll down. And now we can create a subplot and set the figure size. Since there are 10 classes, we want to display the first image, and we want to display the first image from each class. We want to create a 2x5 subplot where 2 refers to the number of rows and 5 refers to the number of columns. And each figure will have a width of 22 and a height of 10. And now we will create, well, we'll set an index used to access the elements in the class names and images list to 0. And then we create a nested for loop to loop over each column in each row of the figure, and we access each element in the subplot and set the title by accessing the class names list, and display each image using the IamShow method by accessing the images list, and the index is then incremented by 1. Okay, so now we can run that. And here is the output. And now the first image of each class in the train directory is being displayed. And notice that even though the figure size for each image is the same, the images themselves are not all the same width and the same height. And in later tutorials, we will set the images width and heights to be the same. And now we will define a function called countData, which will be used to count the amount of data in each directory in the train directory and in the val directory. And this will be achieved by creating an empty list called counts. And then we will loop over each class name in the class names list and set the count equal to the length of each directory found in the train or val directories. So for both the train and the val directories, the count will be the number of files found in each subdirectory or each class. And to get the length of each class, we need to convert the file path to a list, which is done by using the path by passing in the provided path, which is done by using the path module by passing in the provided path to either the train or val directory, and then we will concatenate the class name to the end of the provided path, and using the glob method we will be able to access each file in each class. And the ** is used to access each file name, and the /* is used to access the extension of each file. And each count is then appended to the counts list, and then after the loop is completed, the counts list is returned. So we can execute that cell, and we can now call the count data function and get the count of each file in each class in the training data set by passing in the file path to the train directory, and similarly we get the count for each file in each class in the validation data set by passing in the path to the val directory. And we can execute that cell, and we will scroll down. And now we can create a pandas data frame for the training data, where the columns correspond to the class names found in the class names list and the count of the number of files in each class found in the train directory. And then we will print out the first 5 rows of the data frame, so we can execute that cell. And we see that the Tench, English Springer, Cassette Player, and Church have 1,300 files or images, and the Chainsaw class has 1,194 images. And this data frame is used by Seaborn to create a bar chart for visualization. And first we set the figure size, then we use the bar plot method to create the bar chart, and here the vertical axis corresponds to the number of images found in each class and in the training directory, and the horizontal axis corresponds to the class name. And if we run that cell, now we get the bar chart, and here we see the vertical axis corresponds to the count, and the horizontal axis corresponds to the class name. And notice that each class except for the Chainsaw class appears to have 1,300 images. And we can repeat this process for the validation set by once again creating a pandas data frame, printing out the first 5 rows of the data frame, which we will do here after running this cell. And we can visualize the number of images once again in each class in the val directory by displaying the bar chart using Seaborn. So we can execute this cell, and we see the bar chart. And notice that each class in the val directory contains only 50 images, which is substantially less than the number of images of each class in the train directory. And the number of images used for each class for the train and val directories was determined by the creators of the Imagenette 160 dataset, and can of course be adjusted when attempting to train a more robust model. Alright, so that's it for this video. In the next video we will demonstrate how to create a custom convolutional neural network, or CNN, using TensorFlow and Keras. And if you found the video helpful, be sure to comment, like, and subscribe, and if you have any questions, leave them in the comment section below. Alright, we'll see you in the next video.